In this final lecture from Chapter 4, we'll give the basic relationships for probability. We will learn about the complement, the union, the intersection, and mutually exclusive events. In addition, we will learn about conditional probabilities. For each of these, we can use a Venn diagram as a simple description. For the complement of an event A, it's the sum of all the sample points that are not in A. So in this circle, which is event A, in the total rectangle of the sample space, anything which is not A is the complement of A. For example, the complement of a stock making money are all the possible ways that it will not make money. The union of two events, event A and event B, would be all of the sample points that are in A or in B or in both. So the total of those two circles inside the sample space, which is the rectangle. Key on the word or, and note that the symbol designated union is the inverted cup, which looks like a wide U. Using the investment example data, the union of oil stocks being profitable, or mining stocks being profitable, or both being profitable is described here as the probability of the union of M and C, M or C. The intersection of two events, event A and event B, would be the set of all sample points that are in both A and B. Let's key on that word and. Note the symbol designating intersection is really the inverted symbol for union. In this case, the intersection would be only where the circles for event A and event B overlap. Again, using the investment example, here we can see the probability of oil and mining stocks both being profitable. There are only two events, but that's the case, so we will sum up the probabilities of those two events and end up with a probability of 0.36. The addition law allows us to relate the union with the separate individual or marginal probabilities of A and the marginal probability of B, as well as the intersection of A and B. This is written as the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection of A and B. If we think from a Venn diagram standpoint, and we add up the probabilities of the two circles A and B, A or B, we have to be careful to not double count the intersection where they overlap. Therefore, we have to subtract that intersection. Using the investment example, we know that the probability of mining stock being profitable, of oil being profitable, and the intersection of both, that allows us to use this addition rule. Therefore, the probability of the union is equal to the individual probability of mining being profitable plus the individual probability of oil being profitable minus their intersection. In some cases, two events can be mutually exclusive if when one occurs, the other cannot occur. Using a Venn diagram, we would see that there is no overlap, therefore there is no intersection. Can be applied This can be applied to the investment stocks. Now, the multiplication law allows us to relate that intersection with the conditional probabilities. Now, all of the previous examples, the final probability relationship we need to know about is conditional. The formula for conditional probability is equal to the intersection of the two events divided by the probability of that given event, or what we are conditional upon. Using the investment data, we can calculate the probability of mining being profitable given that, or conditional upon, the oil stock being profitable. Using the separate values we've already calculated, then that probability of mining stock being profitable, C, conditional on oil stock being profitable, M, gives us a probability of 0.5143. The multiplication law allows us to relate that intersection with the conditional probabilities. Again, applying that to the investment stocks. Now, all of the previous examples, the investment stocks, and their intersection, union, and conditional probabilities could be a bit confusing. But the logic and calculations can be made much easier if we put the separate probabilities into what's called a joint probability table. This is exactly the same concept as we used in Chapter 2 with cross-tabulation of two variables of data. Most of the text examples and homework problems can be best described using a joint probability table. From this, we can find the intersection, the union, the total or marginal probabilities, and conditional probabilities. Finally, we need to understand that two events can be independent. In other words, the probability of event A is not changed by the existence of event B. Events have different forms of conditional calculation. And the multiplication law is simplified given two independent events. We describe that here for the investment example. But please do not confuse the idea of exclusivity and independence.